All right, this is the second subtraction problem, which we're going to do in 2's complement. This is going to require me to put together a 26 and a 37. So let's put together the 26. That'll be a 16 and 10. So that'll look like this. So my value will be, for just plain 26, 0, 0, 0, 1, 1, 0, 1, 0. And then a 37, I'll delete these values off of here. And 37 then would be a 32 and 5. So that would be one of each of these. That's 37. So that would be 0, 0, 0, 0, 0 on the rest then. So my value for 37 is 0, 0, 1, 0, 0, 1, 0, 1. Now I'm going to flip them over to 2's complement by flipping each of these to their complementary value and then adding 1. So this was my 26. This is my 37. Let's flip each one of these over. This becomes 1, 1, 1, 0, 0, 1, 0, 1. And then this one become 1, 1, 0, 1, 1, 0, 1, 0. Plus 1 to turn them into 2's complement values. So when we put the 1 here, there's no carryover. I just get the same number again, except it has a 1 on the end of it. And this one's going to have a 0 here with a carryover bit, so this will be 0, 1, 1, 0 on that end. And these two values. These are the two values that I'm going to want to add together to give me my the sum of those two negative numbers. So let's add them together. I get 1, 1, 1, 0, 0, 1, 1, 0, and I'm going to add to that 1, 1, 0, 1. So I guess that would be an 0, 1, and then 1, 0, 1, 1. That's this value on here, that value on top. Let's put them together and add the two of them together. That's a 1 here. This is 1 and 1, which gives you 0 with a carryover bit. That gives me a 0 with a carryover bit. That gives me a 0 with a carryover bit. This is 1 and 1, which gives me a 0 with a carryover bit. There's another 0 with a carryover bit. And now this value here becomes a 1 with a carryover bit. That becomes a 1 with a carryover bit. All right, so that's the sum of these things. But once I add them together, I've got to switch them back out of 2's complement because they're still in 2's complement here in order to interpret the value. So I flip each of the digits like this, 0, 0, 1, 1, 1, 1, 1, 0, and then add 1. Okay, so we uncomplement it to turn it back into regular binary and add 1. So my value becomes 0, 0, 1, 1, 1, 1, 1, 1. Okay, now it's up to us to sort of interpret what that value means. So we interpret that by looking at the two digits on here. That's a 32, that's a 16, that's an 8, a 4, a 2, and a 1. So I wind up getting 32 and 31 out of this because it's 32, 16, and I'm going to call that 15 to add them together. So I get a 32 and a 31, and that's going to give me a 63. But remember that that was a negative value here. That's indicating that front bit being 1 indicates that it's a negative value. So my answer is interpreted as a negative 63 when I pull it out of binary as a 2's complement value. So when I go over here and add these together, I should get negative 63, and I do. This is sort of my check on the value.